bring out the chat. Is there anyone here? I can't see the chat. I don't think there's anyone here now. Sometimes there's a delay on this. I don't know. Live chat. All right, I will see. All right. So I thought, you know, I've been doing some stuff with HuggingFace, but I've never really, you know, gone into it. And I figured, why not do it and do it on stream? Because, you know, it's been chill previously. So the idea is to learn some HuggingFace, you know? Finally. It's been a long time. Long time coming. Super useful library. Probably so for those of you who don't know, there should probably be someone in the chat, right? This is something that's not working, I think. Can someone just, let me see. I know I've had this issue once before, I think. Oh, there we go. Yeah. There was a delay, I think, or something. Yeah, see how now I'm seeing the right one. Yeah. All right, let's just get started. You know, I'm a noob when it comes to HuggingFace. You know, I've used it sometimes, but I definitely don't, you know, I have a lot to learn. So that's what we're gonna try to do in this stream. Just get started with HuggingFace, learn the most sort of important stuff. And luckily for us, they've made sort of a really good tutorial sort of series here, and we'll just follow it. And all right, so HuggingFace, you know, for those of you who don't know, it's kind of the biggest NLP, natural language processing library that's sort of open source and has all of models, data sets, all of that stuff. It even has some other things, like you can train your models and so on. But we'll probably, if we're gonna train something, we'll probably use Lightning, but the models and stuff they have here is insanely good. They have sort of all these models. You can sort of, all right, we want a model for, it's mostly NLP, but they even have stuff for computer vision. So like, all right, we want to do some question answering system. We get the most popular downloaded. All right, we'll use Distilbert, boom, and we can just sort of import it and use it. But the details of that is what we're gonna hopefully learn about. So the HuggingFace system, they have transformers, which is the one I mostly use, transformers, and then they have datasets, Tokenizer, accelerate. I don't know what these are exactly. I mean, you have datasets, makes sense, but how they work on a deeper level, I'm not sure. Prerequisites before going through this course. I don't know, actually. I think basic PyTorch maybe, and I mean, I think they've built this so it's pretty beginner friendly, but all right, it says requires a good knowledge of Python. It's better to take an introductory deep learning course. Does not expect prior PyTorch knowledge. After you've completed this course, we recommend checking out Deep Learning's AI's natural language processing specialization. By the way, just gonna ask you guys, do you think this would be of interest? Because I haven't done this specialization, but it's of, I think the authors of, or the creators of this course are sort of the original authors of Attention is All You Need paper and so on. So I think it's a pretty good course. Would that be interesting to do on stream as well? To just kind of go through the course or something? I don't know, just an idea. But today we'll focus on HuggingFace, of course. We don't have a certification. All right. Each chapter is designed to be completed in 1 week with approximately 6 to 8 hours. So it's 1-9. We'll see if we can do it faster than that, probably, but we'll see. Awesome, yeah. Yeah, might be interesting. We can try it. By the way, is can you hear the music in the background? Is it like good audio level and everything? So this is actually good. Like I have an intuitive understanding of what NLP is. All right, so examples: classifying whole sentences, sentiment of a review, detecting if email is spam, determining if a sentence is grammatically correct, or whether two sentences are logically related. Let's see. I mean, probably it's better to just look at the models, right? And we can see here. NLP, we have text classification, token classification. What's token classification? Is that like NER or entity recognition or no? Okay. Named entity recognition. I think that's probably token classification. Yeah. So it looks like this. All right, and then we have table question answering. I don't know what that is. Question answering, zero shot classification. You know what? I'm kind of curious. I don't know exactly how zero shot classification is done. Cause like, okay, so you create a list of the words that you want something to predict to. Like you input a sentence and then you want to classify your own custom. And, like my idea of how they do that is that they produce some embedding representation of each of the words. So like if you have like let's do tmax create learning HuggingFace. I always forget this. Tmax create. Oh, this is not right. It should be this one. Tmax new learning HuggingFace. Maybe it's better to do this in a Jupyter notebook, probably. We'll see. But yeah, what was I talking about? Yeah, zero shot classification. Yeah, so I think like what they do is like if we do, if we have like a list of like cat, something's wrong. It's Vin. Yeah, so if we have like a list that's like cat and dog, and you can do your own sort of custom, right? I think what they do is that they run, maybe someone can confirm if this is right or not, but I think what they do is they run through the model and you get some type of embedding for sort of for your sentence, or embedding for like a sentence. You have something like this, and then you run it through the model, and you get some type of embedding, and then you get an embedding for each of the words, and you check sort of which is the closest in distance to this particular to this sentence or whatever. I think that's how they do zero-shot classification, but hopefully we'll learn exactly how they do it. All right, so then we have translation, summarization, conversational, text generation, text to text. All right. Classify each word, generate text, extracting text. So these question answering systems are really useful. Yeah, so this is where I figured we could start. Let's see if we can do this. Probably it would be better. Let's see. We'll do. We need to install PyTorch. We'll try the nightly one. Because why not? My intuition is that you create a nice latent space during training, so you can interpret, extrapolate on that space to generalize. Yeah, that's what I'm thinking too. But they must sort of send through the sentence, right? And they take the output from sort of the previous layer before what would commonly be sort of the classification layer is what I'm thinking, and then they get that dimensional whatever. And then they run the exact same through on each of the words that you want to classify, and then they do some kind of similarity metric, like cosine similarity or something between the classified words that we want and the sentence. This is, I think I'm using Copilot, so I think that's what you're referring to. I'm using Mac and then SSH into a Linux machine. Yeah, no problem. You're welcome. All right, so let's do pip install Jupyter. Was it Jupyter Notebook? Jupyter Lab. So let's see how we do. So if we do Jupyter Notebook, it's 8888. Maybe we can do. I think Jupyter is probably nicest to just play around with stuff, right? I don't know. I don't like. Sometimes I use Jupyter notebooks, especially if I'm exploring data and stuff. But I think this might be nicer. All right, so we need to pip install transformers. So this is like the basic one that is most convenient to use, right? This pipeline, and you can do. I mean, it's dumb in like how simple it is to use. So now, like if you do from transfer import pipeline and you set just what you want to do, like sentiment analysis, and then just run it, you can get it out like 3 lines of code and it works. Yeah, okay, so if you watch the Whisper fine tuning, I actually completed it just after the stream. It was really like small difference from what I coded during the live stream, but I have the code done. Maybe I can push it to GitHub and you can see it there. Or I could do, I'll probably do like a project with it, and then I can do a tutorial on Whisper fine tuning. So what I did on the stream was fine tune Whisper with PyTorch Lightning, and yeah, I tried it on some task and it worked for the example that we did on the stream. Yeah, there are many benefits of using Linux over Windows, I'd say. I don't know, like there are edge cases. In 99% of the cases, you're fine with Windows. Yeah, we'll go through the course, and I think they cover it in it. I have not tried Tailscale. Actually, never heard of that. Tailscale, check that out later. All right, let's see. So pipeline is nice. What else can we do with pipeline? Yeah, okay, so what is done here? So the text is pre-processed, I guess tokenized. It's run through the model, and the predictions are post-processed. And these are the ones we have of some of the currently available. I want all of them. So all right. All right, so you can also send in the model config and other stuff here, and the device. All right, so here are the tasks. Let's see, we have audio classification, automatic speech recognition, conversational depth estimation. What? Okay. It's weird how it's like an NLP library, but you have depth estimation. Seems confusing. document question answering, image classification as well, object detection. What? Okay, they have a lot then. What's default and by the device and stuff? Get the vector representation of a text. So if we do, will it re-download the model maybe? No model was supplied, defaulted to distilled bird cased. Using pipeline without specifying a model name and revision is not recommended. Okay, that's nice. PEFT. They added team library. Okay. Yeah, the team library is awesome. I'm good, Andrew. How are you? Alright, so should we try some of these maybe? Fill mask. Or alright, we'll probably try them later on. Zero shot classification. So this is what we were talking about. So you can just input a sentence, you can get candidate labels and it'll sort them for you and say that this is about education, probably. So it doesn't have like it doesn't know what the transformers library is, perhaps, because it's like deep learning and machine learning. All right, I mean it's correct, but it's not very certain. And I don't know if you knew this. I'm trying out the Chat GPT Plus, and like the biggest benefit so far is like if you do AI. So first of all, I don't know if you know that if you just do AI.com, I guess they bought the domain, so it goes a lot faster. So just like AI.com. And with the, like, I don't know if it's worth it to buy it, to be honest, but I'm just trying it out. So, like, you don't have to verify and all of that stuff. So you just get automatically, that's nice. And then you have access to some default model here that's like optimized for, it's higher in inference speed or something. What did it do? So in this course we will teach you, okay, let's see if it understands large language models. Large language models work by the assumption that the person who is expressing an attitude. What? Okay. I don't know what model that they're using there, but I think ChatGPT is probably better. Yeah, it's probably not the best. So it would be interesting to know what they use by default. Okay, default to GPT-2. I mean, they've come a far way from GPT-2 to like from this to this, right? I actually don't know what the difference is. So this is the default, and then the legacy one. I don't know, I think it's more compact or something. Yeah, I think it's generating slightly faster, but not that noticeably. I haven't tried the Bing AI, but I've seen a lot of people play around with it. I kind of agree with, I sort of agree with Jan LeCunda like he says that you can't trust these things. I mean, they make stuff up pretty often, and for sure, I don't know. In the end though, it's like there's a lot of bullshit information, and you sort of have to learn to classify things already, right? So it's not like you use ChatGPT and you trust it blindly, you sort of but at least it's useful in many cases, even though you can't trust it. All right, what else? Text generation, and you can use a different model. So let's say we want to use, let's go back. So if we go to models, can we use a better one? Text generation here. There we go. Oh, okay. So let's try GPT-J 6 billion. This is a large one. I wonder if I can do this one. I think I can. All right, so if I want to use this one, I can just, I guess, copy this. And we'll do model name. No model was supplied. We'll do task equals, and then model equals. All right, cool. And oh, it's gonna download 24 gigabytes, and it's gonna take 18 minutes. Oh, okay, I don't know if we want to wait that long. Probably not. Let's do, 66 billion. Holy shit. I read about this one. So this is, I think, the largest open source right now. I know the Encoder AI, they have 20 billion as well. I don't know if it's available here. Encoder 6 billion, 2.7. There we go. Here's the 20 billion. I mean, it's insane that you have all of these like available so easily, right? You can really see how amazing this library is. Yeah, the problem is with the Discord, like I've never been a person that uses Discord a lot. I don't know why. I know it's amazing. I use it for gaming and like chatting with people while I game, but I've never used it for, I tried creating the server, right? And my goal was to have sort of a community where people can, like, if somebody has a question, they can ask it to me and I can sort of help them, or just sort of discuss and share memes and stuff. But I don't find myself to be that active on it. Oh, okay. There's a 176 as well. 1 billion larger than the largest GPT-3 model. They definitely did that just to, you know, show who has the big guns. Did I stop this? No. Yeah, let's stop this. But I'm curious to see, like, when I played around, by the way, with this, I've played around with this GPT-J 6 billion, but it's definitely not in the ballpark of the equivalent version of OpenAI. So they definitely have a larger one. But we can try this. I think it should probably be better. I don't know how large. Let's stop this because I don't want to wait that long. All right, that's faster. So you can also do num-return sequences and max length. That's nice. So I guess they'll do both of them independently, I guess. What's the difference of running it 2 times and just doing, is it more efficient or no? I guess we can try it. All right, so do this. And then we'll do that. And we'll do what was num words? Max length. Max length is 256. Can you do like a min length as well, I guess? Okay. Large language models work by using the language model to describe the language model. Okay, I mean, this is trash. We need a better one. Let's... Is there like a medium? Do you guys know, by the way, which like is the on a lot of TPUs, I think that's insane. Oh, again, can you link this thing? What is it? State-of-the-art parameter efficient fine-tuning. All right, you're going to the advanced stuff, right? We need to learn the basics first. Maybe this is for day 2 or something. All right, we'll do this at a future, but we know that it exists, and we'll see how large we can fit on 2 3090s. Yeah, I do think there's a temperature. There's probably a bunch of stuff you can do. But I think they probably have pretty sane defaults, right? In this scenario, I think it's just a model that's pretty shitty. We can try this one, and we'll just wait for it to be done. All right, I'm gonna be my disk space is gonna be full pretty quickly downloading these models. All right, mask filling. Okay, so this has 82 million parameters, so it's super tiny. Is it also using... So we wanted to try, let's see, we wanted to try this if we do num return sequences equals 10, and we do a, let's time this, and then let's do, I'm kind of curious just if it's faster or not, or if it's just for convenience. What's this? Pythia 410, dated 10 days ago. What is this? It's a collection of models developed to facilitate interpretability research. Okay, all right, it's cool too. Here we have Bloom. Do you guys know what's the best kind of, like, what's the best language model right now for the equivalent number of parameters, not just absolute, but is it Bloom, is it GPT Neo or J, or I guess we can just try them out, right? You get a pretty, we can ask, I mean, instead of asking the chat, let's just I'm gonna automate you guys, okay? I'm gonna ask ChatGPT, what's the best in the HuggingFace library? There's a lot text generation models such as GPT Neo and Stillbird, Bard, and even and other. I guess it won't know about this. Other ones such as what's the I mean, it won't know. Yeah, and it's a dumb question. I mean, ChatGPT is good to be like, that's a dumb question. All right, I can't, it's not there yet. To like, you need to do prompt engineering on that. Let's see. Okay, so we wanted to try GPT Neo 2.7, and then I want to try, let's see, what else do we have? I guess popularity is a good thing to go by. If we go to text generation and most downloads, recently updated. All right, these are just from other people. Most downloaded, we have GPT-2, XLNet, GPT-J. We can try this as well. All right. May 3rd, 2022. Yeah, that's true. Yeah, I guess I can. Sometimes when I've tried it, it just okay. Seems to have pretty short, but this was pretty all right, I think. Seems to be on the right idea. Can you do it on all of them? No? Okay. So I guess you can do it on some, but not. Oh, you can. Okay, so let's do this. So this is the 6 billion one. By representing sentences vector embeddings, most of them present. So far, I think I like this one the most, but it's too short. So I think we need to try it. But anyways, what we wanted to check here is if we do 10 return sequences, and I hope this is running on the GPU by default. I really hope so. Oh, it's not? Well, that's dumb. What? Device GPU 0. That's actually dumb. It should be some type of warning if it's not doing it on the GPU, right? I feel so. What do you think? Language. It takes a long time to load this as well. Okay. That's cool. And we can do named entity recognition. Question answering, summarization. All right, cool. I mean, this is like the most basic thing, right? And it's probably the most useful in CUDA. I feel like they could have said that from the beginning though. Like, why did you have to load a 10 gigabytes and then be like, hey, you can probably do the assert on the device first. It died. Okay, so how do we actually set it on the GPU? Oh my god, I did that? Well, that makes sense. That makes sense then. Well, we can't have that. So that's why it's probably, we don't have to specify the device probably. If it's CUDA, it's probably gonna run it automatically. All right, so what's the summary? In each, I mean, I skipped how transformers work and all of that stuff. You saw how to approach different NLP tasks using the high-level pipeline function, which seems to me to be the most, I don't know, like if you're doing some type of project and you just want something quick, pipeline is probably the way to go, right? And it seems pretty useful. You can specify the model you want, all that stuff. All right, so then we have different types we have encoder models, which is BERT, and all of that stuff. They use, the encoder is bidirectional, so it looks backward and forward to get the actual output. And so it's useful for sentence classification because it can look forward and backward, named entity recognition as well, and extractive question answering. So you can predict like, all right, in these, on this thing here, you want to extract this part. And that's useful because it can see the entire sentence or the entire text. And so it can output indices from where you want to extract. So that's the encoder part. And then the decoder is just the text generation part. So I think, if you look at the original transformer, right, it was used for machine translation. So the encoder was taking the source language, which was in French or something, and it would sort of get a representation by seeing the entire thing. And it might want to not only look backwards, right, but the decoder is sort of to produce the output. And so it's best for text generation. And this is just like a GPT model. And they so GPT is just a bunch of stacked decoders, and BERT is basically a stacked encoders. And then you have some models that use both encoder and decoder, so similar to the original paper. Are you guys still here, by the way, or did you leave? Seems quiet. I wonder how many viewers there are. Oh, 18, damn, that's many. Maybe it's frozen again, or nobody's writing anything. I don't know. Okay, it still works good. All right. Sometimes it's like freezes and I don't know. All right, so let's see what we can do with this end of chapter quiz. Oh, explore and look for Roberta large MNLE. I mean, it should probably do text classification and maybe summarization. What do you guys think? Without checking, I think it should do. Roberta is like a BERT model, right? So it's encoders, and that is used for text classification. This one is right. Summarization, I don't know. I don't think so, actually. I'm not sure. If we have grouped entities, it will return the words representing persons, organizations, or locations. All right, I think that's right. What should replace ... the mask? Or maybe this, but the example we saw was that, right? Oh no. All right, this. Why does this code fail? Because you don't have entity candidates or candidate labels. This pipeline requires labels. The transformers library is broken. Okay, what does transfer learning mean? I guess a large language model doesn't need labels for pre-training. I mean, yes, right? It's just text. Select a sentence that best describes your model, architecture, and weights. Which of these types of model we use for completing prompts with generated text? How many questions are there? A decoder? Or maybe a sequence to sequence? Which of these we would use for summarizing? Sequence. Maybe like this is better. Which of these would you use for classifying text? An encoder. A possible sort can be bias. Oh. Okay. No. Alright, I didn't look at this one so carefully. An architecture is a succession of a mathematical function built with weights are those functions parameters. Alright. True or false? A language model usually does not need labels for its pre-training. What does transfer learning mean? Maybe it's this one too, I'm not sure. Alright, it's that one. It will return the word. Okay, and then this. Alright, cool. Let's go on to the next. Alright. Yep. I don't know. I'm trying to become one right now. I'm creating the roadmap live. Alright, so what did we learn about? Now this should probably work. Or do we need to probably need to reinitialize, right? Yeah, I think so. Maybe it doesn't work because I haven't played around much with the. All right, let's just do this. I don't need to create an environment now. Which ones do I have? Yeah, Whisper Lightning should probably work. Is it essential to know all the details behind these large? Wait. Is it essential to know all the details behind these large language models? No, I don't think so. There are a lot of things I don't know how they work, but I can still make them work. But it might be nice. And also, but yeah, I don't think so. Do you set the device here maybe? Because this is gonna take too long otherwise. One thing is, like, if you do if you use ChatGPT and it tells you something like this, like that's what I think. But if I do something like it says in the documentation of Hugging Face that it actually does something more advanced which reduces inference time. Okay, so you see, like, I'm saying something that is just false, but then you're correct. Hugging Face uses a technique called beam search, but beam search has nothing to do with this. Yeah, well, anyways, yeah, I think the latency is pretty fast, right? If that was what you like on the stream, I mean. So, like, when do you hear this? Okay, that's not too long. That's maybe like 15 seconds. Okay. All right, cool. So it ran. It did it on wall time. No, it does do something smarter, right? It must do something smarter, because look, if we just do return our answer, and let's just do answer. So the first one, non-return sequence is equal to 10. I guess it does it batched, right? So maybe that's the difference. It just does it batched. It does a batch inference instead. So I guess like if you look at here, it uses 18 gigabytes, but then, oh. Okay, I'm not sure actually. But it's definitely faster for some reason. All right, cool. It's just good to know. I'm not exactly sure what's the difference is though. I'm curious how they actually run this, but it must be batched is my guess. Or it just does some initialization, which takes a long time, but I mean, this is a big difference. All right, let's see what it says then. Print answer. Large language models work by learning a function from data and applying it to different languages. A common and successful method for learning the function is recurrent neural networks. Okay, I mean, like, this one is not good either. This is not good. I would not want to use this. And if we use the Bloom thing, how good is this one? This is a small one. Bloom 7 billion. Let's do 1 billion. What a time we live in, huh? Just to be able to do this. Boom. All right, let's try it. Boom, boom. What are we learning in this? Using transformers. All right, let's read this. Transformers are usually very large with millions to tens of billions. Training them is a complicated undertaking. All right, so this is what the transformer library wants to do. Ease of use, downloading and using. They've definitely succeeded in that. Flexibility, all models are simply PyTorch. All right, cool. So you can integrate them easily into others. That's what we saw when we did Whisper fine-tuning with Lightning. Simplicity, hardly any abstractions are made. I would say this is a little bit, it's true that it's simple, right? Using pipeline is simple, but if you want to get into the details of how it works, it's not very simple because there's so much engineering behind it. But yeah. The last feature makes transformers quite different. Has its own layers. I mean, like, it's still the best, right? But it can definitely be difficult. Sometimes they want to make it they want to make things a bit too easy for you, I would say. All right, so we'll focus on this chapter. Will begin with an end-to-end example where we use a model and a tokenizer to get to replicate the pipeline function. All right, cool. So we get into a little bit more detail. Then we look at the Tokenizer API. Tokenizers take care of the first and last processing steps, handling the conversion from text to numerical inputs. All right, cool. So let's understand what happens behind the pipeline. But first of all, large language work by learning to predict the probability of a word given a context. All right, cool. The most popular language models are the n-gram models, the conditional random field model, and the bag of words model. The n-gram model is a simple model. Probability conditional random field is more complex. All right, it's okay. I mean, GPT-3 is a file system that is used to store data in a. Oh, it is, right? Okay, wait. What does the language model GPT-3 work? How does it? Okay, wait. All right. I forget all the time. It's not a chat model, right? The language model GPT-3 works by the details behind the by OpenAI works works as follows. The model is trained on a large data set of images, which is a combination of images from the image and data. Okay, this is, yeah, I don't know, guys. There's probably some way to reduce it. Yeah, probably. I mean, this is not perfect. But all right, I mean, it's, yeah. All right, let's see how we do this. So auto tokenizer, let's see. Behind the pipeline. So you have the tokenizer that takes raw text input IDs, you run the model, and then you get the predictions. Pre-processing with tokenizers. Transformers can't process raw text directly. It splits the input words to tokens, maps each token, it adds additional inputs. All right, so if we do auto tokenizer, okay, so it does it batched, and then here it's gonna mask, right? It's gonna mask this one because it's not, it has padded it, and okay. All right, so we get the input IDs. All right, so that's auto tokenizer. Oh, okay, so you need to specify the exact one. Okay. And we can do our model as well. System. Yeah. What is it? It's a GPT file system. Oh, it's hilarious. All right, so we have many different architectures available. We have model to retrieve the hidden state. Then we have for causal language model, for mass language model, for multiple choice, for question answering, for sequence classification, for token classification, and others. That's a bit confusing. So what if we just initialize the model like this? What will happen? We will get, what's the shape of this? 16. All right, so we have 16, and for each of those 16, for each of those 16, we have an output. All right, so we get one for each, and then how do we? Okay, that's not correct, but I didn't really expect it to get that. Oh, okay, it does, but we need to have the sequence classification head. And then there's an auto model for sequence classification. Okay. Okay, so now it's actually 2 by 2 as ChatGPT said, and it's yeah, so this one is positive and this one is negative. Cool. All right, and then we need to run softmax. Maybe we should like just get an overview. They have auto for everything. ML. Yeah, they seem to have. Wait, let me just. All right, so for question answering, for multiple choice, for sequence classification, what is this architecture is designed for sequence classification, where the goal is to give it a sequence to one of the possible classes. For token classification, okay. Model.config.id to label. Okay. 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 Cool. All right, what else can we do? So this is, if we go to HuggingFace and we go to models, this is sentiment. Where is that? Text classification. Okay, it's this one. And we have a bunch of other ones. Maybe we want to do token classification. Let's do this one. And let's take this model. And now we need to change it. So if we do auto model, then we're gonna specify this. This will just return the last one, but if we want to use, I guess it would for token classification then, and we'll do this auto model for token classification. We'll use this checkpoint instead, and we'll just, okay, so this actually does all of it for us, because here we send in the input. Okay, so we still need to do this part. All right, to actually run here. All right, so it ran it, and then if we do this, it should okay, this is not correct. Well, let's see. Print outputs. and 0. And we don't do this here. I'm a bit confused. Inputs. My name is Wolfgang and I live in Berlin or something. Okay. So that's the input. And it's 13. But the outputs is just 1, 2, 3, 4, 5. Oh, it's not correct. Okay, wait. So it still ran if you use for sequence classification. Okay, but it should be this, right? Auto model for token classification. All right, cool. And then we get 0.shape. So we should get 13 and something. Yeah, 13 and 5. So if we do that, all right, cool. So here it says organization, I guess, or so we have 0, then we have, I don't know what it stands for, outside of a named entity. All right, so we have for the first 4 here, so I guess that corresponds to this. We have that, and then we have here, we have 2 for Wolfgang, which is a person, and it's the first one, so that's correct. And then, all right, so you need to just remap them because you need to know which one corresponds to what here, depending on how it's been tokenized. But at least we got it to work for that too. Maybe we can do, let's see. Nerves, yeah, I looked into nerves a while ago, but right now I don't really have any project that will involve nerves. So it will I'll probably come back to it at some point. I love your positivity, Kai. Okay. Alright, cool. I think we succeeded on that. Let's see the model. In this section, we're going to take a closer look at creating and using a model. We'll use the auto model. The auto model class and all of its relatives are actually simple wrappers over a wide variety of models available. It's a clever wrapper that automatically gets the appropriate model. Okay. Okay, so this is for masked LM. Cool. For masked LM, and we use auto tokenizer and auto model, and that's how it does it. And then print output. So this is a what did this do? Fill mask. Okay. But we should do this, I guess. Yeah. So encoded input for pass, and we predicted probabilities. Get the top K towards top K. Convert IDs to tokens. All right, cool. So we take this, copy paste. Oh, we can do this. Copy code. Boom. So automatic, I want to buy a new car tomorrow. Encoded from forward pass, predicted probabilities, output.logit 0. Why is 0 here? The first and only example. Okay, that makes sense. All right. All right, so we get the top. Let's print it. or let's run it. It needs to download it, right? Oh, let's see if ChatGPT can fix it. Oh, see? It shouldn't be that. It should be this. So what's actually happening here? We do output.logit 0, for example, encoded input of input IDs 0. We make it to a list, and then we index. All right, okay, so we get the column that are the probabilities for I'm not sure actually. Let's print output. Okay, so we have 25,000. What is this then? Right, this thing. I mean, it should probably be 4. So okay, the mask token ID. All right, okay, so it takes out 11 for each. For every word, or in the tokenized in our text. What's actually happening here? I'm not sure. So we get the 4th column, which is what? And then what do we get here then? There should be 11, I guess. Yeah. Let's do that. Oh, it's 25,000. Okay, we get actually the entire thing. Right. Okay, wait. So we're getting. Oh, okay, wait. Okay, I understand now. Right. Okay, so we're getting 25,000 for each, right? It's predicting the actual word for each of them, but obviously we only want to have the one that is masked. So we get the index for which one is masked, which is the 4th index in this case. And then we look, all right, for every word that we predict, what are the top probabilities? So we just rank them, and then we convert it into the actual word. But the probabilities is not correct here. So this is the code. And it seems to work, but we get output, which means that the It's not really a probability. What went wrong? Yeah, so it probably just missed the softmax because this is not predicted probabilities. We need to do softmax here. Okay. Okay, that seems to be correct. Cool, nice. All right, let's continue. Let's see, where were we? Okay, we're here, models. We have encoded sequences. All right, yeah, we could load it. But it seems like the auto model thing is probably the best, and you just specify auto tokenizer and auto model for masked LM, probably. The question is like, how do you fine tune this thing? And that's what we'll probably get into. Oh, models. We did this. Tokenizers. So let's actually, before we, isn't that the third index? I mean, it depends on how the tokenizer works, right? I mean, here it's not intuitive that it would tokenize it as you are thinking. We can ask GPT. So I'll just take your question. Alright, so here, can you print the encoded input? Can you print the text for each tokenized index so we see exactly how it has tokenized the text? Actually, I'm not sure how you would. I mean, we would probably do the same thing, right? Just tokenizer convert IDs, because we get IDs here, and then we just convert them. So yeah, I mean, we can do this. Encoded input here. So we're going through each in the thing, and oh, okay, we can just do tokenizer.decode. I don't know if you need to do this then, but yeah, so we get tokenized input S in the beginning. Why? Oh, start, I guess. Okay, the start of sequence, right? That's index 0. So 0, 1, 2, 3, 4. Yeah, so you were right. It should be like 3, but it has the start of sequence, so that it makes it 4. Thanks, GPT. Let's get an overview though, like what are we actually gonna learn from this? So we have tokenizers. All right, tokenizer stuff, character-based, word-based, so we get an idea of how they use, handling multiple stuff. So we do batch stuff, putting it all together. Auto tokenizer stuff, cool. And then here we fine-tune a pre-trained model. Cool. And then fine-tune with the trainer. And I will not use their trainer here because we want to use Lightning Baby. So we'll try to do the same thing here, but with PyTorch Lightning instead. A full training example, cool. All right. Nice, and then sharing models. So this is, I guess, useful. The models in the hub are not limited to transformers. They are modeled from Flare, Ellen, NLP, Asteroid, PyAnnotate, and Tim. All right, so using pre-trained, that's nice. And then we go into the dataset library. Load datasets, pre-process the data. I don't like this either. I've tried, like when I did the project with Whisper, there's like, it's so difficult to understand how it works exactly. And I prefer to just, I don't know. I prefer to just know exactly what takes time and do sort of my own custom dataset, and then with Lightning, and then do something to that kind. So I don't know how much we want to, I mean, we'll go through it so that we know how it works, but I don't know if, like this thing, load data sets, and then you have, let's say you want to load, let's do something very specific. Like you have very specific files, and you have some audio files or something, you want to load it, and you have a sort of a text transcription for each that we did in the Whisper fine tuning. And you know, that works, but it's very unclear what takes time, how the code looks like, how do I debug it. It's just sort of one line. And then to go into the source code of this is just like, I don't know. I don't want to do that. Because like here, creating your own data set. Okay, cool. You create your own. But then you need to learn all of these things. We'll go through it, but I don't know if I'm gonna actually use this. From my experience, I want to do it myself, and then you can learn. You can sort of exactly go through what takes time. How can I, you know, make it more efficient and so on. All right, then we have the Tokenizer training introduction. We look at how to fine tune a model. All right, so you might want to learn a new optimizer. How do you train a new one? All right, cool. And then you have a bunch of different types of tokenization you can do, byte pair encoding. And then we have main NLP task, translation. Let's look at that. So you load a data set, you use a pipeline here. Okay. All right, data collator. And then you do a sequence trainer. So this is what we did in the Whisper thing. Instead of doing the sequence trainer, we tried to do it ourselves. Summarization. All right. Actually, it wasn't that in depth that I was thinking, but it'd probably still be useful. Okay. But if we just think if we think in general, like what do we want to, yeah, that would be cool. Training a stable diffusion model, that would be awesome. Maybe we can you know, I would like to have a 6-pack, and I was like thinking, should I do a cut, or maybe I can just fine tune stable diffusion on a lot of images, and I can get that 6-pack. Because like nobody's gonna see me shirtless anyways, right? It's only like on Instagram. Yeah. So we'll what do we want to actually do with this? Like, if we're thinking like, okay, we're just following this like course now, right? But what is that we actually want to do with this? We were here, right, in the tokenizer thing. So I guess like what we want to know is how do we fine tune these things, and how do we load the data set using something other than, or how do we, yeah, so like an entire pipeline of how you would use it. And then they didn't cover more advanced stuff. I guess there are, if we do, I don't know, let's just check what this is, spaces. All right, so we have inference API, Gradio, diffusers, evaluate, right? That's another library, I guess. Tim, accelerate. So accelerate is instead of lightning, but there's the course. All right. And pricing. Yeah. Yeah, I'm trying to figure out what's the best plan here. I'm not sure if I actually want to follow this. Like when we went through this now, like it's a bit too basic maybe. Like we want to figure out what is that we actually want to do. This is just like tokenize and tokenize decode. So what could be what would be like a simple project that would teach us all of the essential stuff when it comes to Hugging Face? Maybe we don't need to, we can just go through this a little bit in more depth. So tokenizer are one of the core components. They translate to text. Cool. We have word-based. There are character-based, subwords, and more. They're byte level pair encoding, word piece. I'm not familiar with like how these tokenization things work or how they're trained and so on. All right, encoding, conversion to input IDs, cool. And then we do convert to IDs. What's the difference between tokenizers.tokenize and... Oh, okay, so if we just do tokenizer.tokenize, then we get the actual tokens. But then to input IDs, we need to do this. Okay. Okay, so instead of doing tokenizer.tokenize, we do tokenizer.encode. It will run both of them. That's nice. And then decode on the input IDs. Alright, that's cool. And if we want to handle multiple, convert batch encode plus. Did it just make that up, or is that actually correct? I have a feeling like encode plus, batch encode plus. Why is it called? Why is it called batch encode plus? What happens if we just do tokenize that encode on the sequences directly? Will that also not work? Also explain padding and truncation. That makes no sense. Like, why would we need to call it plus? In contrast, batch encode plus allows you to tokenize and encode multiple sequences at once. All right, padding and truncation are techniques. Many use a fixed input size, which tells the tokenizer to pad or truncate the input sequences. Oh, okay. I focus on medical imaging analysis. I find a lot of things I not know NLP. I know the basics, but there's a lot for me to learn. Scrape some Wikipedia articles and summarize. Have a look at core competition on Kaggle. I saw tokenize. Where's the embedding? I'm not sure what you mean embedding here. Batch encode plus. All right, cool. I guess they maybe should show that here. Oh, if we just do tokenizer, then if we just do tokenizer directly, what happens? I mean, that's simpler. Isn't this, what's the difference between this and simply use it, or use tokenizer, or using the batch encode plus. Seems to be doing pretty much the same thing now. I've heard about this one too, but I'm not sure exactly what this does. I was using this for a project a while ago, and mandatory end of chapter. You think we should do it? What is the order of the language modeling pipeline? Order. Okay, we first the tokenizer, then the model handle these IDs, which can be something. Tokens handle text, the model handle these IDs, and then it outputs a prediction. The tokens can be used once again. That's how it is, I think. How many dimensions does a tensor output by the base transform model? What are they? The sequence length. The sequence length. No, wait. Shouldn't it be? Yeah, I mean it's those three. Which of the following is an example of a subword tokenization? Oh, I don't know. Subword. Splitting on white space and punctuation. That's not a subword, I think. Is it character based? I don't know. PP maybe? And then character based. It's not subword. Maybe this word piece. Unigram. What is a model head? A component of the Bayes transformer network that redirects tensor to their correct. What? I think this is the answer. What is an auto model? A model that automatically detects based on the checkpoint. Oh, this one. What are the techniques to be aware of when batching sequences of different lengths together? Padding and truncating. Oh, it's not attention masking. What is the point of applying a softmax function to the logits? It applies a lower. It's soft in the large. Okay, maybe this. What method is most of the Tokenizer API centered around? Tokenizer encode. This maybe? No? Oh. What does the result variable contain? A list of strings. Is there something wrong with the following code? Alright, cool. Are you happy? We did the mandatory end of chapter quiz. Man, I feel a bit lost. Maybe I should take a little bit of a break. I feel like when you do, like, you get stuck and you like don't know exactly what the best strategy is. Maybe we should just complete this course anyways. I mean, it's probably not a waste of time, but it would be nice. Like, I'm thinking like we should do some type of project to learn HuggingFace. No. My mind is going off. Why is it going off? I don't know what this means, man. I don't know what this means, bro. Oh, what time is it for you? What do you need help with, man? Oh, it's 10 p.m. Where are you from? Oh, 3 in the morning. Maybe you should go to bed. I know you need to rest your mind so you can play League of Legends and stuff. Oh, okay, so I guess you're like a couple of hours ahead then. Let's see. HuggingFace project. Is there someone that has done something? Maybe they have some examples. I mean, this year probably have some like tutorials that are not just the course, right? Don't they have some type of example in the documentation, maybe transformers, how-to guide? Maybe this is what I'm looking for. I mean, it seems like a fun project, but I don't know what the usefulness is of it. I don't know. I haven't really understood it, but I'm a fan of whatever he does, so if that's what he wants to do, then I'm a fan. Happy to help. I'm glad you found it useful. What are you doing your PhD in? I mean, there's some a lot of examples. Should we do something like this maybe? Fine-tune a question answering model. We can go through that. It would be cool to do some of our own type of project though. But like what, okay, so what have we actually learned so far? If we go, oh, it's still using 20 gigabytes. Let's see if we do, what have HuggingFace. All right, so we started understanding the pipeline. And probably most useful for various tasks, easy to use, or understanding how to use the pipeline, and the different subtasks it can do, like, I don't know, translation, QA, zero shot, sentiment analysis, etc., token classification, etc. Then we understood how pipeline works in more detail by using auto model for various tasks, as well as auto tokenizer, and how we can import. Yeah, I guess that's what we've done so far, right? Now we want to know how to fine-tune a model, I guess. So like how long it takes to reach different. So I don't know if I believe in this class. Like, how do you classify if someone is a beginner, intermediate, or advanced? I don't know. I would say that first of all, things are kind of specific. So you can be a beginner in many different types of areas of machine learning, but you can be advanced at a very specific type of recommender system, you know, and you can be sort of really specialized in an advanced level on that specific thing, but you have no idea how to use, you know, how, I don't know, how ChatGPT works and how they trained it, you know? So I don't know if these classifications are useful in how you classify someone's knowledge level. I think what we should focus on is just like building useful stuff and building things and sharing information with others. That's sort of what I think should be focused on. And then the question is, what is it that you want to do? So what is it that you are interested in? What would you like to build? What would you like to see machine learning being used for? And then we sort of go back from there. So we start with what you want to do, and then we see what do you need to learn to do that. And that way, that's, I think, one of the most efficient ways. But to generate the ideas of what you want to do, you need to have some type of context. And so I think courses are great for getting that context and sort of getting up to speed on updating your knowledge level. But then in the end, you will want to do your own project. 3D object detection. I haven't really done much in 3D object detection. No. I don't have knowledge in that. I don't know what models they use. All right, I'll be right back. Yeah. We'll figure out what type of project we do, but let's just continue from this then. I don't know, like, let's just say like what we want to learn. Can I ask you, like, what would you want to learn for Hugging Face? Like, if we try to get an understanding of what we want to be able to do, like, this is cool, right? The pipeline thing, understanding how it works. We would probably want to know how to load a data set, how to fine tune, What else would we like to do? How to evaluate, maybe. I don't know, I'm just trying to figure out kind of the tasks that we want to be able to do, and then we can work backwards. But I guess this is so how to use the high-level trainer, deploy. Yeah, I think you know, honestly, I was thinking of doing this is gonna be like a big focus of mine for the future, ML ops, and you know, building projects, hopefully open source projects, and maybe we can build them on stream and then deploy them, and that would be like really awesome. I think it doesn't have to be like a complex thing either. Like, we can start with some dumb project, we can make them work, and just you know, show the process and build something that's very niche but can be useful to people. Yeah, we can do MNIST, or we can do something more interesting maybe. Whoa. It's exhausting to like learn new stuff. Like, I feel like I want to take a break now, but I don't know what to do. Because like, we definitely want to continue with this. Like, we want to understand how to fine tune. What do you guys do when you when you take a break? Because now I've been streaming for 2 hours and 15 minutes, and I haven't really taken a break, I would say. Sleep. Could you recommend a good course for computer vision? Yeah, I think I did CS 224 and CS 229. No, 231. This one. I thought it was useful. Especially object detection. This one, and I like the Justin Johnson, Michigan computer vision. This one. This one I like. CS 224. I would say I learned from. Has anyone actually done anything on YouTube for Hugging Face? Hugging Face. I mean, this one we didn't look at the videos. Maybe we should do that. What happens inside the pipeline? Tokenizers, word level, word based. These are too many though. There's too specific. Write your training loop. All right, I'll watch this one for no specific reason.
Medical or legal, or use a different stack.
Okay. Hey, it's me. On this channel, we're allowed to be racist. In fact, it's encouraged. What am I saying? All right. All right, let's check Twitter. What's happening on Twitter? I like this one. Have you listened to this one?
With our innovation, they will definitely want to come out and show that they can dance, and I want people to know that we made them dance, and I think that'll be a great day.
We made them dance. What do you guys think of OpenAI? I saw this tweet from Elon, and it was like how they wanted to create OpenAI was it for it to be open and open source and non-profit, but now, right, OpenAI is basically heavily under the influence of Microsoft, and it's definitely no longer open. It's you know, they have to make profits. Yeah, bro, you gotta be, you know, flowing with this, you know. Can't be too rigid. At the end, we all end up on Twitter. Hey, it wasn't that quick though. It's been, how long? It's been 2.5 hours, okay? Yeah, it's on my to-do list, Stable Diffusion. But what's up, Picasso? How does I haven't tried Bing. How does it work? Bing GPT. head to Bing and click on the chat. Okay, Bing, search the web for Hugging Face. Okay. I have to join the waiting list. How does it work? Okay. All right, we'll just wait 2 to 3 business days and then we'll know what Hugging Face is, guys. We'll end the stream here. We'll be back. Is this with Stable Diffusion? Yeah. All right, let's get back. Let's get back to work. Yeah. Oh no. I love this guy on Twitter. Like, he always makes me smile. XG boost. Like, I don't know. All right, let's get back. Let's continue with the fine tuning. Okay, we gotta do processing the data. Copy paste code. Doing what we do best, you know? Auto model tokenizer labels 1 loss model step backwards. Okay. Of course, just train the model in 2 sentences is not a good idea. All right, how do we load the data? Load datasets. Glue. I don't know what that is. It's a dataset, right? But what's this? What does this do? Microsoft Research paraphrase corpus from the Glue benchmark. The Glue benchmark is a collection of NLP tasks that are designed. Load dataset function from the loads the MPRC. Okay, cool. Oh, it's actually the exact example that ChatGPT gave. Amrosi accused his brother, whom he called the witness, of deliberately distorting his evidence, referring to him as only the witness. Label 1. Alright, this is a paraphrase of this. Yeah, for sure. It's a bit sus, like, I don't know if it's hacked me or not. Imagine though, like, if you have ChatGPT and you would have it hooked up to like all this inspect code, right? Which is basically everything that we're seeing on the screen, and ChatGPT would know how to interpret it. And so you would have ChatGPT hooked up to everything that you could choose, like if you want to specific types of tabs, and then it knows the context or what you're doing, and you can just ask, you know, very specific. You don't have to do prompt engineering that much. You can just be like, what does this mean? You know, you can, and it just knows from the context. What I think about Lambda? What's that? Right, so we do a function that tokenizes one example here, and then we want to map it on our data set. So we'll do tokenized dataset like this, and so we won't actually, this does it for this one, this does it in memory, but it's not general. Does it in memory, not general. Maps on call, I guess. Oh, okay. Okay, and then it caches it that well. Okay, so it does it for the entire body. Oh, you mean that one? Okay, yeah. Yeah, that was yeah, there was a Google engineer, right, that thought it was sentient. I mean, they can definitely explicit behavior that's really like makes you wonder, but yeah, at the end of the day, it's next word prediction, and we can definitely see that they have a bunch of flaws. So. All right, so what are we actually doing here? We are tokenized, we're mapping it, and then if we print it, tokenized data sets. All right, and then if we do train, and then we do 0, and then we have input IDs.
Well, miss, I guess I'll be on my way now.
So what's what here? Sentence 1, sentence 2, input IDs. Okay, so we do a classify, and we're supposed to classify if these two sentences are paraphrases of each other or not. And we have this separator thing here. And then we want to use a collator. Alright, so if we do samples, we run through the first 8 examples, and then we get the length of each. If we then run the batch, then they will all be 67 in length because it's padded to the maximum length one. What do you mean? I'm not leaving the country. What? This is like, I don't know, I think it's pretty chill music. It's like the music I can play without YouTube complaining too. Leaving the country? Where did that come from, man? But you should come visit Sweden. Alright. Fine-tuning a model with a trainer. We did this, right? Okay. We can clean this up a little bit. Does it tokenize processing entire data, or does it do it in on the fly? See, this is the confusing stuff with ChatGPT. So the map method preprocesses, so the tokenizer is applied to a batch of examples at a time. During the training, the map will iterate apply that contains. By processing the data on the fly, the map can efficiently preprocess large datasets without requiring a large amount of memory. I mean, this is true. Okay, but then you're correct, the map does preprocess the data and save it to disk as cache completely on the fly. Okay. Oh, okay. Well, I guess that's correct. The collator does basically padding. So it takes in examples. So it takes in the batch, and the batch will vary on the lengths. So you might have one example that's 20 in length, one that's 67, one that's 52, and so on. The collator is going to pad all of them to have the length of the maximum one. So what's happening here? We load a data set, right? Then we do trainer. I don't know what this training argument is here. Yeah, I don't know what time it is for you, but good afternoon. Yeah, thanks for joining, and thanks for supporting the channel. This is a bit confusing to me. So what's the actual training arguments? Training arguments. Okay. Okay, so we specify the number of GPUs, we specify auto find batch. Optimizer, where do we do that? Atom. Okay. There's a lot of stuff hidden here, right? Yeah, you're right. It's 6 p.m. here. I mean, I'm kind of surprised this works, but to me, this seems a little bit, I don't know. I don't really like this because there's a lot of stuff hidden, right? Okay, so I understand, like, okay, the dataset part is fine. I mean, this is there's a lot of mystery of like how they're actually loading it, but hopefully they will go through how we do it for custom datasets. But then this thing, that makes sense. But then here, like the training arguments, I would like to specify. Yeah, that's kind of how it is. Like, I don't know how any of this works, but it works when you run the trainer. I don't like that part. I would like to, I mean, you're sending the train dataset fine, but like, how does it know? Like, what, it's hidden, you know, the details of how it works is not clear at all. So I don't really like that. That's pretty bad, honestly. I would not like to. I don't like following these types of tutorials because it's too simplified, you know? Like, this is not how, I don't know, maybe they just do this and then they go into more detail, which is fine, but then they have to at least mention, like, by the way, you won't understand anything now, and that's okay. But yeah, and now I have to retrain it as well. I don't know. I don't know how long until it gets boring. Yeah, I guess so. But like, you wouldn't use it for custom things, right? But I'm just thinking how things actually work here. So there's a lot of training arguments here, but how is it specified? How do we change it? And how does it know what to do here? Like, how does it actually work? I guess it's just that it's uncomfortable with a lot of things being hidden in this way. If there are, let's say if there's any errors, right? I have no idea how I would go about it because, yeah. I guess it's just, it might be that as I get more comfortable, I'll understand it. But right now it's not too clear to me. We'll ask GPT. And we can remove this and this. And yeah, that's my worry, that with the dataset part, there's a lot of stuff hidden. So I would like to know, you know, if I'm doing it on a custom one and it's super slow, how do I debug it? Yeah, that's a good suggestion. But how do you, so I want to use Lightning Trainer, right? So I actually just want to learn how to integrate the model and set it up. But it's, I don't know, I guess it's a good idea to still get an understanding of the Hugging Face trainer, but you're right, I would probably not use it. I just want to learn how to do, to me, instead of having like very specific, I don't know, so you can create very specific types of applications where you can build in, sort of build it around it, and it will be super convenient for that very specific use case. But if there's some like edge cases to the use case, you might have to modify it, and then you're going to be in some really horrible situation. So I would rather you just show me one way that's more general, but it might be more code, and I can use that for every task. I just have to adapt it. But the approach is general. But now it's like, okay, you use this low data set, but actually, if you're gonna want to optimize it, you're gonna have to use these special arguments. And hey, by the way, this low data set, it only works for this type. If you want to use this, then you need to change the folder structure, and then actually it's not very fast anymore, so you have to change this. And it's like all of these like edge cases you have to go into. I would rather just have more code, show me how this looks like, because it can't be that complicated, right? And then let me just see the general structure of it and actually understand it. But I don't know. I mean, they have good reasons for doing it. There's a lot of smart people working on this, so this is just my opinion. All right, accelerate. All right, so what's accelerate then? But this is for training stuff, right? Accelerate is training. And again, I don't want to, so here they are competing with Lightning, it seems to me. And I don't know why they do that. Like, I don't see the reason to build something that has the same functionality as something that was built specifically for this. Why do you want to go into the area of competing for the same thing? I don't understand that. Why not focus on actually, it just gets confusing. Yeah. Like, use Lightning, but you have to use Hugging Face for the models and stuff, right? So we want to integrate it with Lightning. But to me, it just seems, yeah, I don't know. Don't understand the exact reasoning. Yeah, that's my thinking as well. Like, we use Hugging Face to load the models, and then we compute the loss. But how? That's what I'm like wondering here. How is things actually being done here? Where is the actual like how do we change this to a, what's the one training step? If we would convert this to Lightning, we would want to have one training step. Yeah, exactly. So then I guess you could go into the trainer here and you could look at the, like how it's being done. I mean, we can probably figure it out, but it's just gonna take some time. All right, let's rerun it with this. So what are we doing here? We're predicting on the validation. We're doing argmax. We're doing a compute metric. I guess we don't need to do this. The trainer contains the training. Okay, we can. I wonder how good. So if we put everything on a single one, we can go into this source code maybe, but I can't type. Oh, I need to import it. Something's missing, right? Where is where is the trainer? Where did I import that? Let's go back. There we go. I don't know how their structure is for training. Callbacks, train data loader. There should be some type of training step here, right? Train. In the train, we're running hyperparameter search, resume. All right, inner training loop, get train data loader, running for some steps. If we have deep speed, stuff. Here we go. Self.training step. Perform one model inputs. Loss, compute loss. of model and inputs. All right, we run the model on the inputs, and I guess the model knows, right? I guess the model has a specific type of structure, right? So if we look at this thing here, we have sentence for this specific type, which is this auto model for sequence classification. I guess we can look at that. So maybe it's not that much work to look at how they compute the loss and then do it for one training step and just convert it to Lightning. But I'm just curious, how do they know what it needs to be specific, right? Here, like in the actual inputs for how it computes the. So basically what I'm asking, or what I'm confused about, is here how this should be structured. Oh, you don't need to rewrite it. Oh, because it's computed in the model, you're saying. All right, okay, it's in the outputs. Okay, that's, I guess that's convenient. Okay. Nice. So like, what would you say, or what is your point of view of why is Hugging Face also having a trainer? I mean, I guess I understand they want to have it like all in one library, but yeah. All right, okay, so the trainer, the loss is computed in the model. We're sending in the training arguments. We're sending in the train, val, data collator, compute metrics, and that's basically most of this stuff is done in the model. All right, well, that's good to know. I appreciate the saving my time. But so for loading the dataset, what do you actually use? Because my idea, so when I've tried using a load dataset with Hugging Face, I feel like there are, sometimes I don't understand how they're actually loading stuff and how to optimize it. So it's very hard to debug what's taking time. And what I did instead is that I used sort of a custom data loading class with PyTorch, and then just use that one in Lightning data module. And then you can sort of optimize for one sort of in the get item, right? And you can sort of time each individual part of what's actually taking time for data loading. But here, what they want to do is basically give you, a very convenient way to load the datasets, which is nice, but it's a black box. And if it doesn't work, or if you just want to optimize it, it's very unclear on how to do it. So basically, do you actually use this load dataset for custom datasets, or do you just use it for the ones they have pre? Yeah. And that's also, okay, so that's my experience as well, that you have to kind of rewrite it from scratch. Yeah. But yeah, I guess like it's convenient when they have a lot of standard data sets like this. This is nice, and hopefully they've made it. Yeah, I agree, but it would in the general case you would still need to rewrite it because you're doing your own sort of on your custom, I don't know, whatever. If you're working for a company and you have this custom data set, you would need to rewrite it, and you would need to do it from scratch basically. Okay. Yeah, because I did one project and I tried to use this load data set, and after a while I figured out that, you know, this is super slow and I have no idea what's going on, and then I just rewrote it. This was when I tried, this was actually on stream. I tried to rewrite and fine-tune Whisper using PyTorch Lightning, and I wanted to know how to load the dataset exactly, so I just rewrote it into a custom. It was a lot faster than this load dataset. I think I used load dataset HuggingFace audio folder or something. This thing, load dataset audio folder, and like it works, but it's super slow and you have no idea what's going on. So it's like they've tried to do it for custom, right? They've tried to, like, if you write it sort of like for in PyTorch, you have this image folder, right? I think it's called that image folder PyTorch. Yeah, this one, where you basically have like if you have a specific structure, you can just use this and it will load your custom data set instead of having your own custom class. And that's nice that they've made it this way. So it's custom. You just specify the exact same structure, but when you have that structure, you like, I don't remember exactly what it was, but it was actually I don't remember. It was just slow, and it cached all the files, and I didn't want it to cache the files. I wanted to load them on the fly. So what it did, it had like 1 terabyte or something, like a large data set, and then it wanted to load it and save it as cache, but that's a lot of extra space, right? So I just thought it was, but it's good to get your point of view. So I mean, it seems like we have the same thought. You would use load data sets if it's like something that's very well known and you want to fine tune it on it, and it's like standard, but for custom you still need to write your own. What's up, Anai? Yeah, HuggingFace is nice. I like it so far. There's a lot of details on how you want to use it. I feel like this course here is like, it's nice. It shows you an overview, but I think in practice it's a bit different for how you would like most practically code things if you're not looking for like the easiest way or the cookie cutter way, so to speak. You want a general way. But anyways, where were we? So we were trying to understand this compute metric thing and the all right, so we did this, and here they also used accelerator. I mean, this is, if we're gonna use Lightning, I don't want to even spend time learning this, to be honest, because we're not gonna use it anyways. So what's the point? All right, fine tuning check. All right, test what you have learned. The emotion dataset contains. I have no idea. Search for, I don't know. How does the bird expect pair of sentences? Classify, separator, like this, I think, or this, I don't know, one of them, like this. What are benefits of the dataset map? The results of the functions are cached, so it won't take any time. But this is like, I don't know if this is good or bad. Yeah, the mandatory quiz. Like, I don't know if this is good or bad. Do you want, so you pre-process, right, the data, and then you save it to a cached file, and these cached files will be like, they will be compressed, but they will still be large because they contain your entire data set. So what I used, like when I ran out of space, I had to go through and like look at the Hugging Face cache folder and like remove, because it made new cache depending on how exactly I pre-processed the data as well. So I don't know. I'm not, like, how I usually do things is just find a way. It can apply multiprocessing. Yeah, it does not load these things. What does dynamic padding mean? It means you pad your inputs when the batch. What is the purpose of a collate? It ensures it puts. What happens when you initialize one of the auto model for? I don't know what this is actually. Nothing, but you get a warning. No. I don't know. I didn't look at this. All right. Sharing models. We already looked at this as well. How we can use it. It's stuck. Wait. Oh no. Huh. No. That's not good. All right. No, it's not you. It's not you. It's me. Wait. Let's see. If I remove it, what happens? It's still stuck. Yeah. All right, there we go. Wait. Properties. All right. There we go. Does it work now? Yeah. I think it should work now. Awesome. I don't know, should we do this one? Maybe we should just skip this, like sharing the models. Who wants to do that, you know? If we're gonna do this, I guess we can look at it. But it might be useful to know like how you so like if we go to a model here and we go to this one and then we go to files, is there something here that's actually, all right, we get the config, the bin, is there anything else? Model card, and many of them don't have one. So. Yeah, I have like a lot of ideas right now, but I'm just wanting to like, you know, start to execute on stuff sort of. Like I did that. So we did a stream for the PyTorch Lightning, right? And this like that series is complete, and hopefully will be nice to like for people to get started with Lightning if they want to. And I want to do sort of a similar thing for many different types of topics, but I don't know, like now I need to learn about Hugging Face and get a better understanding, because I'm gonna use it for some consulting that I'm doing. So I'm gonna fine tune some models, and I need to get you know, up to speed on how to do it in the best way. So I want to learn Hugging Face, but then I was thinking, you know, I could, you know, when I've done some projects on it and so on, I can try to make a series on that as well, just for the Lightning series. So that's my idea right now. And hopefully I'll have the time for that. But sort of my general plans right now is so like specifically now I want to learn about Hugging Face because I need to for work. But then I would like to do a series on it. And then I need to take some time to update. Yeah, good night, bro. Thanks for joining the stream, Balram. How do you pronounce it? Balram. But then I want to update my knowledge in a bit. Like it was a while since I did a few courses, and I thought that maybe, I don't know if it would be nice or not, but I was thinking we could maybe go through some stuff on stream. So like, I would like to do this this ML ops specialization. No, not this one. This one. I would like to do this one, just because I don't know. I like Andrewing and whatever he does. Billy, all right. Good night, Billy. So like, I don't know. What do you guys think? Would that be something that's interesting? Like doing this on stream? The thing is though, I don't want people to like, if people find it interesting, I want them to actually learn about them themselves. So I don't want it to be, I don't know. I just want to make it like a chill stream where we learn about different type of concepts and stuff while going through the course, and you can sort of chat about it as I go through it, and can be a more chill way of doing the course, if you're like, for some people, I guess. I don't know. So this is like ideas I have. I don't know if it's a good idea, but then I was also thinking of doing NLP specialization, and I also want to do ML ops. So there's one made with ML, I think. I have some stuff that I want to follow. Just updating my knowledge on some stuff. Since, yeah. So those are my ideas right now, and graph neural network is definitely part of that plan. The course on MLOps is very bookish. What does that mean? Like it's because like I want to learn about the terms and stuff, like the concepts and all of that. And in the past, I've liked the deep, like in general, I like what deep learning.ai produces. So, but I do think that some like Stanford courses are more in depth in some ways. But in general, the deep learning AI are sort of a good introduction, I'd say. But let me know like what you think would be a good idea for streams. Like I'm still trying to figure out streaming and how to integrate it. Yeah, thanks, man. I appreciate it. Okay. Yeah, I mean, we need to learn both, right? So it can still be good. But I don't know, like the general idea of doing like what type of streams I can do and what would be interesting. In general, I try to integrate like YouTube into whatever I'm doing. So like I need to learn about this for work, or I need to learn about this for a school or whatever, and I try to, you know, share it and try to explain it the best way I can and shorten the learning time for others. How many viewers do we have? Yeah, I'm doing my thesis now, my master's thesis. But I'm working as well, so... Oh, we have 16 viewers. Damn, that's a lot. So right now, like what I'm doing is basically doing my thesis, and then working part-time, and then I want to do YouTube on top of that to sort of just share my journey and what I'm learning about. So that's the goal of these streams and the videos. Maybe a paper reading stream. Yeah, so this is one thing I thought about as well. Like what I would like to do is get some people that are interested in reading papers, and then do a sort of a call on like Google Meet or something, and we sort of go through the paper together and sort of discuss it, and hopefully like we prepare it in some way so that people have read the paper beforehand, and then we write like some points that we want to discuss, and then we create a discussion regarding the paper. So like things that we thought were interesting, things that were confusing, and just have a general discussion on it, and then maybe share that on the YouTube channel. But I haven't really, I need to like think about how we structure it and how it would be nice to also, yeah. By the way, I can't see the book collection you made. I don't know if it doesn't post the link or something. Yeah, that would be interesting. So consider calling someone with practical experience in a particular field and let him show some project. What do you mean, like on something you're working on? On something he's working on and he explains it, or how do you... But that would be cool. Like I would want to do more of what Yannick is doing, and sort of interviewing people would be cool, and getting people that are, you know, maybe, you know, can share things that would be interesting. Yeah, that's a good idea, man. That's a good idea. I wonder how we get in contact with those types of people, but that would be really awesome. This G drive link has Python data science folder. Okay, I don't get the link. I don't know if this like blocked or something. Building a diffusion model from scratch and stream it. Damn, I mean that's hard stuff, right? But I'll think about it. I can't see it. I don't know. Can you guys see it? Can't see the link. All right, let's try to be a little bit productive as well. So what we wanted to do, okay, so should we just skip this? I don't know. So what do you do when your dataset is not on the hub? How do you slice and dice? What do you do when your dataset is huge? Yeah, I agree. Like, I think it's probably very simplified, but I was thinking, long term, that's what I would like to do, is how, like, taking a black box model, or taking like a project we make and then deploy it, and make it open source. That's sort of one of my big goals I have. But for that, I need to update my knowledge on ML ops and, you know, all of that, and maybe even learn, you know, some Flask and, you know, or Fast API or whatever. Yeah, but MLOps project, that's definitely, I'm definitely gonna do that. And that's a good idea for stream as well, because, you know, this is my idea. Like, we would build something, like a project that we actually want to have, something that's actually interesting, or, you know, hopefully can be useful. And then my idea is that we'll make it open source and sort of have it on GitHub, so like it's all available. But then my goal is to like have it so people can use it for free, because like there's so many, like if you want to like remove watermark from an image, right? If we just like, okay, we want to remove watermark from image, and we go to this and like, all right, cool, they have it. All right, and then we're like, all right, we want to upload this image. All right, let's take this. Boom. All right, it's processing. I mean, this looks super cool, right? All right, download. Oh, okay, now it actually worked. Maybe it does work. I don't know. I try. Okay, so I tried this, and it's like, okay, but you have to pay this, and you have to become, like, here you go, like, all right, you have a discount here. It costs $90 a month, and you can remove a lot of watermarks. But like, this is super basic, and it wouldn't be that complicated to do, right? So why we can do a project in this and like deploy it and have it actually usable, and not, I don't know. Yeah, I saw that Yannick is doing the chat, open chat? No. What was it called? Open Assistant. I feel like Open Chat would be better named than Open Assistant, don't you think? All right. I'm losing focus, guys. What do we want to do? So we have this. What if my dataset doesn't? What if we can't load it? Then you do this thing, but it's not actually how we're gonna do things in general. So I don't know if it's worth learning. Loading a remote dataset, slice and dice. Big datasets to the rescue. we need to come up with a project. I think that will be the most useful, probably. All right, so let's say we want to, okay, we go to models. Let's say we want to do a sentence similarity. Yeah, by the way, I think AI Epiphany, Alexa Gordick, he's doing like a series now on MLOps. And yeah, it's really good that people are starting to do this more, because we need to learn this, right? Like, we need to get good at actually deploying stuff. We don't want to be the, you know, be the people that just build notebooks on our local machine and be like, whoa, this is awesome. You know? So I think this is great that he's doing this, and I'd like to follow his steps in the future, like to do this as well. I was thinking, like, can we, so this one, right? It takes a source sentence and it compares it to other sentences. Can we do some type of project on this and fine tune this maybe? And we can do everything. Need some help on a unit architecture. I have 26 classes. I have 26 classes of output. I have 45K images. After training the model, it's not that good. Yeah, I mean, that's pretty much impossible to debug. Like, it could be a million different things. Have you tried overfitting a batch first? So that you know, like, the training is good? It could be hyperparameters, it could be wrong in the training setup, it could be, you know, it could be dataset issue, it could be, it's so complex to debug that. But I would say try to see that it works on a batch first. If it works on a batch, you know that the training works. Maybe you can try to optimize the hyperparameters a little bit. And okay, so that works. Is it quick to overfit to one batch? If it's quick, like, you can, I mean, 45,000 images sounds good, but yeah, like, what's the issue? Or why is it not working well? Yeah, it might be a difficult, yeah, it could be hyperparameter related, or it could be also that task you're asking it to do is quite complex. I don't know exactly how the data looks like, but 26 classes is a lot. I think it could be. Right, yeah, that's the one. That's the one I thought about full stack deep learning, but I forgot the name. This is the one I want to follow. Yeah, okay, so let's go back. Yeah, the goal for the day. I mean, the goal was to get started with Hugging Face. The goal now is realizing that we probably don't want to do all of these details of how they do things, because I don't know, there are probably better ways of doing it sometimes. So the goal, I mean, the best, right, would be to do a project goal, learn how to, like, I was thinking we could do a project on this using sentence similarity. I mean, it basically doesn't matter. I mean, I would guess 26 classes is a bit much. Like, it depends on the output, but you can, like, it also depends on the task. Is it easy for you to do? Like, if it's very easy for you to do, I would imagine that the unit can learn it. But 26 classes, it seems like there can be a lot of nuance, and it might not be super clear sometimes. Question answering, okay, we could do that as well. But we need some type of data to train it on. Like, what do we want to do question answering on? Question answering, like, we just want a simple project. It doesn't really matter. Wiki corpus. Preferably, we want to have like some small custom data set so that we learn everything. So we learn load the dataset pipeline. I don't want to use like load dataset from Hugging Face. We can, but I want it to be custom. So we need to load it for ourselves so that it's actually general. And then datasets on NLP. Should we do something like this maybe? Fake and real news classification. So that would be, what would that be? Text classification. What do you think? Can we take some of this? But we want, okay, so financial statements, docs. Is there, do you know a data set for it? So what would you actually want? Like, how does a financial document? let's, I mean, I did something, I did a while ago. Maybe we can just take a look at that, by the way, because I did, what was it? Was it in more advanced? Maybe I put it. I need to change this folder structure. Fine tuning Whisper. So here we did. Okay, so here's the Whisper thing. Whisper.py. Okay, so here is the one with Hugging Face. This was the notebook that I followed. This is their code. So they use this. Okay, so they use this load data set. They loaded an example one here, and the test set, and then they used a feature extractor, tokenizer. Gave an example, Whisper processor. We did common voice. Yeah, so we casted it to 16,000 hertz. And then we did a prepared data set where we run through get input features and get labels. We created a custom data collator that padded it the exact way that we want to do it. Then we computed metrics, and then we got the model, and that was the training arguments, and then we used the sequence to sequence trainer. Now we converted this to a lightning module. So we did two stuff. We did model, Whisper fine tuning, and the Whisper data set. So if we go to data set, here we did a custom class that basically did a get item. I know this is a lot of stuff now, but yeah. Then we did data collator, and then we created a lightning data module for the Whisper data set and the train loader, and that was pretty much it for that. And then we did the model, and we did one training step, which was basically run the model on the encoder input and the labels, and we get the loss and we return the loss. I guess like this is general, right? But we could maybe do a more, I don't know, some type of project with it to do it from scratch. It would be, I guess, similar type of structure. I'll think a little bit. I'll go get some water. Be right back. So like the goal, right, is for us to, instead of going through all of these things, right, is that we want to take some simple data set and we want to learn all of the components of Hugging Face for this specific type of project. So we want to do like the low data set stuff. We want to do trainer and all of that, set all of that up. And we don't want to spend unnecessary time on like data scraping and stuff. So it needs to be like a clean, I mean, like one thing obviously is like if we go to data sets here, maybe they have something that's like just super easy. So here, this is the most popular, super glue. What is this? Super glue is a new benchmark style. Yes or no questions. Sentence 1. Okay. Or like, okay, so what I'm thinking is we want to learn the internals, or we don't want to learn, we want to learn how all of the components of Hugging Face actually work, so that we know, all right, this is how low data set works, this is how the trainer works, this is how we set all of it up, this is how we can integrate it into Lightning instead. And then like the goal is to learn that stuff, right? If we incorporate, all right, we want to scrape the data, then that would be like a chunk of our time to do that. We want more to like, how do we load the data set, you know? I just feel like following this course is nice, but it would be better to have a project that we work on, in like some simple one that so we can learn like for ourselves. I think that's better. So maybe we can start with just taking a data set here. I don't know what this is, open web text. So what's this? An open source replication of open web text. Oh my god, this is, it's not that large, it's quite large. Maybe not that then. Big science, what's this? Given the following passage, generation later, what group is mentioned last? Okay. Giving the following, a generation later, the Irish. Note that the answer is present within the text. Question: what concept is mentioned first? Okay. So what is this? Is this a question answering system or? is this data set? Oh, it's a bunch of different ones. Okay. CNN Daily Mail. Article highlights. Alright, so this is summarization, I guess. Okay. It can be used for abstracting and extractive summarization. I don't know what the difference is. Yeah, so we would do it with stable diffusion, I guess. Abstraction and extract are two different approaches to text summarization. Oh, not question answering. All right, sorry. Okay. Okay. In extractive summarization, the summary is generated by selecting a subset of sentences. Okay. Kind of like cut and paste. In abstractive, summary is generated by first understanding the meaning and then summarizing your own words. Yeah, all right. Thanks. All right, let's take this then, and we'll try to fine-tune a model on this. I don't know how large this is though. Hopefully it's not too large. All right, so first of all, how do we get this data set? We'll go here. What do we want to load data set, create, initialize a model, and trainer, and so we can fine-tune. Okay, so auto model for sequence LM, is that part of the that we followed before? Course. Let's see, using transformers, models. Behind the pipeline. There we go. It's not here though. For auto model for sequence to sequence. And others. Non-exhaustive list. Where's an exhaustive list? I think that Microsoft is making Google dance. So I was thinking we would take this. Let's see, I don't know if this is correct or not. Yeah, exactly. And then when I ask ChatGPT, we get that it initializes automodel for sequence to sequence language model. I would like to know what more exists. All right, so if we load data set, we use a T5 small sequence training arguments, data collator, preprocess, we map it, and we do the trainer. Now we would like to, we want to add a metric to this, and we would want to change it so that we load the data set. So I wanted to just take a data set that they have, use all of their stuff, like their sequence trainer, and we'll expand it and change it to use Lightning instead. And we'll try to make it general for this example. So we try to, maybe download the data set and load it. And so we'll change this. So imagine we have it on disk instead. How do we load it instead of just doing that? And then how we convert it to use a more general training structure. Maybe that's a good way of doing of learning the functionality, I'm thinking. Yeah, I want to first use their functionality, and then we want to know, all right, when does it break, basically? Like, if we download this data set, how do we actually load it? And then we want to load it using their way, and then we'll compare it to the general way. We'll compare sort of speed difference and so on, and to get a better sense of like, okay, maybe it's not so bad, or so basically make a pros and cons comparison so that we get a better sense of it, and then compare sort of, all right, if we use Lightning instead, how does that work? And then we can compare. That's what I'm thinking. why we're getting an error for this. Could not locate. I have a question. Are you considering building a tech startup or join FANG or other companies? I don't know. I would like, for now, all I want to do is get better. I feel like I have a lot of things to work on and sort of develop my skill in various sort of topics, but sort of what I'm most interested in right now is to build sort of open source project that can be useful and expand my YouTube so that we can, you know, build a channel and just get more resources to build cooler stuff. That's kind of my goal right now. I don't know why it does this. Use fast. Okay. All right, I mean, that's fine, I guess. But so what we want to know is, okay, we have the data set. If we go to raw data sets, train, and then 0. All right, so we have article, and then we have highlights. Okay. And if we go back again, we have ID. All right. I think this works. It's just, it shouldn't be, for in examples of document, it should be article, I think, and then highlights. Yeah, this probably actually works though. If we just change this to article. Following the question asked before, do you think that with YouTube channel you can get some money and build a business with YouTube? I don't know, maybe, but maybe if you get like sponsorships and stuff. I haven't done that though, so I don't know how much money you can generate on that. But like my idea is YouTube doesn't generate that much money, but it's fun and I like doing it. But maybe long term it can generate more money with, you know, sponsorships and stuff, and that can build sort of a, but I think my idea is more to do consulting, which I'm doing now. So do consulting, and that you do that for work, and then you can, so with the like consulting jobs, you can funnel the YouTube channel to get exposure, and then you can basically get more consulting jobs, right? That's my idea right now, to sort of generate revenue But you know what I really want to do is build project. So to me, that's what I want to do, like develop my skill, build project, and with more revenue we have more resources to build stuff and actually have them deployed, because it will cost having servers and stuff. But that's my idea, and then hopefully, you know, the projects can maybe also generate income. I'm not sure. How much in average do you get with YouTube ads? I don't know. It's like I don't know, like maybe $400 or $500 maybe a month, which is not that much. How much do you spend creating a video? I don't know. Like the thing is, I want to integrate it with what I usually do. Like it wouldn't be feasible to work just on making videos. I learn things because for example, now I need to learn Hugging Face for stuff I'm doing, so I can just as well like share it. And I'm getting, you know, I like streaming and stuff, so it's nice. Isn't getting the consulting job the hardest in tech? I've gotten a lot of people actually ask me, you know, can you, you know, we have this, we want to build this. Do you think this is something that you can do? You know, maybe they find something similar that I've done a video on, and so they ask me, you know, can you do this? And you know, that's one way of getting consulting jobs for me. So that's sort of my idea. And I think also, like, if you build stuff that's useful, a lot of people will get, like, if you build a skill and it's actually useful, then you can easily, you know, you can, it's more difficult to build a skill than it is to find ways of monetizing your skill. But, you know, this right now, if you ask me probably like 2 or 3 years, I'll have a much better answer, because now I'm sort of trying to figure it out, right? I haven't even completed my master's degree, but this is my thought process. Did it work or no? Yeah, it did work. Okay. So it was just the articles thing. All right, so let's try to dissect this a little bit. What's actually happening here? And we want to have some type of, let's see, where do we set eval steps, save steps, warm up steps, logging steps, 100. This is like, it's so much to like knowing where to start. I mean, we need to have some type of yeah, we will get to deploying for sure. I don't know when, but it will happen. So we need to have an evaluation metric, right? And then we, maybe we don't have to take it. So pre-process, we're taking the document for documents, targets, tokenizer, we're tokenizing it with tokenizer as target tokenizer. maybe try reading something. That usually helps, but it can be boring maybe. Oh, I feel stuck on this. All right, I mean, we need to understand the data stuff. So let's take this and try to understand it first. Here. Oh. Take this. Put it here. Data set. Data set. Cool, we have that. Now we have the data set here, and then we have this. So we'll just focus on the data set for now. We can keep this probably. All right, so if we do print raw data sets of train, right, we have article, highlights, ID, and then we need to pre-process it, right? So we'll do pre-process function of pre-process example, maybe. What did they do for the one we saw previously? Where did they do it? Here, tokenize function. So we'll do this, tokenize function. Example, and then we'll return tokenizer of example of article, and that needs to be, let's see, input text or article summary. This is Daily Mail, which is like a summarization data set. So tokenizer of example of article, and then truncation is true. And we can do that here too. All right, like this. So we have the article in the summary. We'll do tokenizer of that. So then we have the article, the summary. What is actually outputted here then? So we have model input of labels. Okay, is that how you do it? Oh, okay, so what's actually model input? It's tokenizer of input. So if we do this and we print article, what do we get? Okay, so we get that, and then we want to set label in it. So we'll do this and So that's it, right? But with tokenizer.as target tokenizer. Alright, so the only difference is this is batched, but whatever. It doesn't need to be. I mean, we can just as well use this. I mean, but I don't know. I guess I understand it now. It's just doing it batch, so that's why it needs to do a for loop as well. So this is what, maybe we can do streamed equals true. Is that how you do it? We'll do this. Yeah, I don't know if ChatGPT helps. It doesn't give the right answer sometimes. Streaming equals true. It doesn't even exist. I think it's streamed. No? How much time I spend per week learning? Well, it's a difficult one to answer, I think, because I don't know. It depends a lot, to be honest. Like I'm a person who likes to work in sort of sprints as well. I'm not that consistent. I'm consistently inconsistent, you know. I like to be absorbed in work and only think about work, but then you get tired of thinking only about work, so you want to take a break, and maybe then I think about like playing games or something, and I think only about that for like a couple of days, and then I'm like, now I'm bored of playing games, I want to get back to work. So I don't know, maybe, I don't know, actually I have no idea how much time I spend. Also, I try to think but I do try to focus on deep work, so I try to spend time actually getting absorbed in work and finding fulfillment in learning and trying to better myself. I like that idea of improving, and But yeah, I think, yeah, so it's, I actually don't know. I should track my hours. It's probably a lot lower deep work hours than I think it is. What is it then? It should be streamed, right? Okay, so it is streaming equals true. Dataset. But the urgency to do something in a specific period of time hinders with my learning. I personally learn the best without any pressure. I think it's different for different people. Some people don't put a lot of pressure on themselves, and then you need to have external pressure. But if you're already a person who puts a lot of pressure on you, because for some reason, right, you want to be a high performer or something, then I think external pressure just makes it worse, because you already put a lot of pressure on yourself. So it's just too much. So I agree with you. Like, if you put a lot of pressure on yourself, then you want, and I do. That's why I try to put myself in situations where I can. I let my personal sort of self-inflicted urgency. Yeah, it's, I guess. Damn. All right, let's see. Let's see. It doesn't do this streaming thing. Streaming. Oh, we need to change it to a generator. See, this is why I don't like this, because I don't know, it's preprocess, generate examples. We go through it and we yield a model input. All right, we need to do that to be able to do this stream thing, I guess. So where's the data set? Raw data set. And we're not doing a map. So where are you using it then? Preprocess generator, there we go. Okay. All right, let's try that then, because that seems to be a better way probably. So that's what you have to do to load it in memory. You need to convert it to a generator that does this and then yield. But should it be here or should it be? Shouldn't it be? Afterwards? I don't know if I trust this. Oh, okay. So it returns one example. Yeah, I'm not too like, okay, so how? All right, so if we keep it inside, then it's gonna yield one example. I wonder also, why does it have different max length here? I guess it's shorter. Oh. Let's see what we get if we do this. So we need to create the generator here. We'll do this. Train dataset is this. And now hopefully we should be able to go through this. Okay, so how do we actually... Okay, cool. Okay, no, it doesn't print anything. All right, so we get one example here, and it's a list of lists, I guess. So if we do example of input IDs and we do length 32, okay, so that makes sense. I don't care too much where I work. It's more if I enjoy what I'm doing, and that could be wherever. I just like developing my skill, building useful stuff, and that's it pretty much. Okay, so cool, we have that now and it actually works. It's gonna load it. This is like more general, I would say, because there's no way we're gonna cache the entire data set. So, all right, now we have the actual training data set here. And if we do this now for this, and we can do val data set as well. So we have weight decay, we have now train epochs. Num train epochs equals 10 maybe. I don't know like how long I started. I mean, I actually just when I started is when I started making YouTube videos basically. So like everything, like my journey is pretty much documented from the start. So I guess it's like, I don't know how long ago it was I made my first video on PyTorch, maybe 2.5 years ago maybe, or something like that. 3 years maybe. Actually don't know. All right, let's see if we can run this. Oh, what happened here? Oh, this is not what we want. There we go. So now it should, I mean, now it doesn't cache it, which is nice. The caching would take 8 minutes. So now it should hopefully just, max steps needs to be specified. Okay. We'll do max steps equals 1,000. This is a problem. This is the problem with it doesn't even exist. Come on, like you just make stuff up. Makes no sense. Literally just made it up. It has no idea. And look at this, like, okay, hey, train data set length isn't an argument. You're right. I apologize. Oh my god. Oh my god, it's so lost. It's just trolling us at this point. Oh god. Alright, you know what? Should we just go with the initial plan? Like, why are we doing this generator thing? Because we want it to load on the fly. Because that's the only way we're going to be able to compare it. But I think we didn't. My brain is like working on like 50% capacity now. Like, what is wrong? How do we do this? It needs to know the length, obviously, of the data set, which it can't do here. But where do we send it in? I'll create a data set from a generator. We have documentation, yield. All right. I guess we need to do this iterable data set. What are we doing? That's a good question. Right now we're trying to load daily CNN on the fly using a generator. And we need to, when we do that, we lose the, what's this, shards? Dataset from generator. Okay, we can do that maybe. And dataset. My generator. I feel like this shouldn't be so difficult. Like, we are just wanting to load the data set on the fly, and we need to create a generator for that because we need to map it. But it should not be this difficult. You should definitely be able to send in the length, I feel like. Can we maybe try that? Series of metric as well. This is basically what we're doing. And then what's up, Mert? What error did we get? Let's just try and run it and we'll see. Yeah, I probably am done with coding now. So like, I don't know, when you get stuck like this, it's just better to. Thanks for joining the stream, Anai. Good night. I'll be done for today. I feel like I'm stuck on this, but let's just summarize like what we want to do. So like goals, what we want to like, what do we want to do? I think like implement full training pipeline. From data loading of daily CNN, whatever it was called, dataset, to model training, evaluation, etc. Using HuggingFace. So right now, stuck on the fly data set loading. We don't want to cache because this would take disk space, etc. So that's where we are right now. So after we get that working, we want to go deeper on every step. So download the dataset and load it as a custom dataset rather than using HuggingFace simple API or whatever, in order to make it more general. Compare with loading the dataset as a custom HuggingFace dataset or using a PyTorch class together with Lightning. Speed difference, convenience. Just to get like an intuitive sense of it. And then also right, so then also want to use the lightning trainer, so see how we can integrate that, and then compare HuggingFace to the lightning plus HuggingFace model approach, and see what we like the most. That's the goal, right? That's what we'll continue with. But today was we got an overview of HuggingFace. There's definitely a lot to learn, but you know, one step at a time. Yeah, I agree. I think integrating it is pretty simple. But we still want to use that instead of the HuggingFace trainer, and basically get a sense of how difficult it is to integrate, you know, speed difference, which one do we like the most, and so on. So that's the goal. So we'll continue from this when I stream on this the next time, if I don't solve it off stream. Yeah, I have a Linux VM. All right, guys, that's it for today. It was almost 5-hour stream, so it was pretty good. All right. Bye-bye, guys. Good night.